Hi folks, Dr. P here. This is question number 10 from the probability assignment. Use the given information to calculate the probability of the indicated events. Tanya and Fujiko are two of the competitors in the final of the long jump competition. The probability that Tanya wins the competition is 2/7, and the probability that Fujiko wins is 1/5. Calculate the probability that Tanya or Fujiko wins the competition. So what we're looking for here is the probability that Tanya or Fujiko will win the competition. Okay, so this is an example of two mutually exclusive events because they cannot both win the competition. Only one of them can win the competition. So this is a mutually exclusive event because only one person can win. So let's write down what we know. We know that the probability of Tanya winning is 2/7. We know the probability of Fujiko winning is 1/5. And we want to determine the probability that Tanya or Fujiko will win. So we're going to be using the formula here for mutually exclusive events, which looks like this for this particular example. So it's going to be probability of Tanya or Fujiko winning equals the probability of Tanya winning plus the probability of Fujiko winning. And it's just a matter of plugging in those probabilities. So it's going to be 2/7 plus 1/5. We're adding these two quotients, so we need a common denominator. The common denominator is going to be 35. This is 10 plus 7. So this is 17/35. In B, in a group of students, the probability that a student chooses at random, the probability that a student chosen at random walks to school, we're going to call that W, is 0.35, and the probability that a student has blonde hair, we're going to call blonde hair B, is 0.2. If the probability that a student has blonde hair or walks to school is 0.45, calculate the probability that a student has blonde hair and walks to school. So we have the probability here of walking to school. That is 0.35. We also have the probability of being blonde haired. That is 0.2. We also have the probability here of the student having blonde hair or walking to school. So that is probability of blonde hair or walking to school. That's 0.45. And we're looking for the probability that the student has blonde hair and walks to school. So we're looking for the probability of blonde hair and walking to school. So we're looking for the overlap. So these two events here are not mutually exclusive for two reasons, really. First of all, you can certainly imagine a student being blonde-haired and walking to school. So both events are possible at the same time. The other hint here that these are not mutually exclusive events is that this number here, so the probability of blonde hair or walking to school, is not equal to the sum of probability of walking to school and blonde hair. 0.35 plus 0.2 is 0.55, which is not the same as probability of blonde hair or walking to school. So that would be sort of The second indication here that these are not mutually exclusive events. They can both happen at the same time. So we're going to be using the following. We're going to be using the following formula for not mutually exclusive events. It's going to be probability of blonde hair or walking to school equals probability of blonde hair plus the probability of walking to school minus the overlap, so minus the probability of blonde hair and walking to school. We plug in the probabilities that we have. So it's going to be 0.45 equals to 0.2 plus 0.35 minus the probability of blonde hair and walking to school. And now it's just a matter of rearranging this expression to solve for the probability of blonde hair and walking to school. And if we do that, we're going to get 0.10 or 10% chance. And finally here we have the last question here. Mohinder is playing with an incomplete deck of cards. When one card is selected at random from the incomplete deck, the probability that it is a heart is 0.3 and the probability that it is a face card is 0.2. If the probability that the card is a heart and face card is 0.1, calculate the probability that the card is a heart or a face card. So let's write down what we have and what we're looking for. So we know that the probability of selecting a heart card here is 0.3. Right, it's right there. We also know that the probability of selecting a face card is going to be 0.2. And we also know that the probability of selecting a card that is heart and face is 0.1. So the probability of selecting a heart and face is 0.1. And then we're looking for the probability that the card is a heart or a face card. So we're looking for the probability that it is a heart or a face card. So again, these are not mutually exclusive events because we have this situation right here. We can have a card that is both a heart and a face card. So we're going to be using the formula for not mutually exclusive events. So in this question here, it will be the probability of heart or face card equals the probability of heart plus the probability of face card minus the probability of heart and face. We plug in the numbers that we have. So the probability of heart or face is going to be 0.3 plus 0.2 minus 0.1. And this will give us a probability of 0.4 of selecting a card that is heart or face. All right? I hope that helps. Until next time, may the math be with you.